We're going to talk today about symmetry and rotational symmetry. A figure is said to have symmetry if you can get it to map onto itself. For example, if I have a perfect heart and I were to fold it on that orange line, which we would call the line of symmetry, would it map onto itself? And the answer is yes. So this would be the line of symmetry. Okay, not all figures are symmetric. Okay, so if I were to draw a line of symmetry here, there is nowhere that I could draw it where it's going to map onto itself. Purposely made it kind of skewed looking. So this does not have symmetry. Some figures have more than one line of symmetry. So if I have a rectangle, I could fold it this way and have it map onto itself, or I could fold it this way and have it map onto itself, which means that this point would now fold over to here, and this point would fold over to here. Or if I did it the other way. If we have a figure such as a regular hexagon, I'll do my best here to draw one. So a regular hexagon. Regular hexagon means that all sides are congruent and all the angles are congruent. So that means that all these are congruent. So if I were to draw a line of symmetry, I could draw one here. So this point would be here. This point would map onto this one. This point would map onto this one. I could also draw a line of symmetry here. And I could actually do it diagonal as well. And I have another one right there and right here. So this one has a whole bunch. So we have 1, 2, 3, 4, 5, 6 lines of symmetry. To figure out rotational symmetry, we usually think about it in terms of less than 180 degrees, because if I turn it 180 degrees, whether I turn it this way 180 or going backwards 180 and doing like the 270 and the 360, it's still going to be the same degree since we were going clockwise or counterclockwise. So usually we just go up to 180. So there's a formula. So if I do, 360 divided by the number of lines of symmetry. So in this case it is 6. So 360 divided by 6 gives me 60 degrees. So that means every time that I rotate this 60 degrees, it's going to map onto itself. So if I call this point A and I rotate it 60, it's going to take me up to here. So now A would be here. Rotate another 60, it's going to take me here. Another 60 would take me over here. So when you're doing increments of 60, you would add them all the way to 180 degrees. So this is its rotational symmetry. The other thing we're going to talk about is order of rotational symmetry. Order of rotational symmetry is the number of times the shape fits onto itself in one turn. Okay, so if we go back up to this would have 1, 2, 3, 4, 5, 6. So it would take me 6 turns to get it back to where I started. Okay, so this would be the order of rotational symmetry. Okay, so the next thing we're going to talk about a little bit is horizontal and vertical symmetry. And a lot of times I like to reference the alphabet. So if we were to write the capital letters of the alphabet, kind of like what you would see in an elementary school class. Okay, so if we have the alphabet here, some letters have horizontal symmetry and some have vertical symmetry. An example would be C. I can, actually I'm going to tweak it just a little bit. I can draw a horizontal line of symmetry, and this point would be here, and it would be symmetric. H has a vertical line of symmetry and a horizontal line of symmetry. Then we have letters like R that have no symmetry. So we have horizontal symmetry, vertical and horizontal, and then none. So sometimes we'll have a challenge, if you will, of trying to come up with words that have horizontal symmetry, for example. So the word check. I could draw a line of symmetry, and it would reflect onto itself over the line of symmetry. Okay, just some examples of that.